So, hi everyone, my name is Balazs Bucsay, and I'm going to present you the zero-day hunting, aka the story of a proper CPE test. I'm a Hungarian hacker. I came from Hungary, that's the country in the middle of Europe, the red one. And a little bit about me before I start the stuff that matters. At the moment, I'm a research director at MRGFitas. On the right side, you can find my picture. As you can see, that's my casual work dress. I wake up every day and dress into the dress. We take the security really seriously in that company. I have 4 strictly technical certificates listed on the slide. And I previously worked as an ethical hacker for 10 years in the last 11 years. I started to hack around 2000 when I was 13 years old with Ringo debuggers and disassemblers. And I had one major project in 2009. It was called G.I. John. Please raise your hands if you heard about this project. Yeah, I thought so. It wasn't so famous, unfortunately. It was a patch, a distributed patch for John the Ripper. With that, you could crack passwords with a web UI with different machines. That was the time before the John started to support MPI and other distributed kind of cracking. One more slide about me. There is my web page, my Twitter account. If you like my presentation, please follow me. And there is my LinkedIn profile as well on the slide. I had presentation around the globe. This is my second time in the US, so thank you for inviting me. The first time I had my presentation in Atlanta, Georgia, and I had other presentation around the globe in Moscow, London, and so on, mostly in Europe. My last presentation was about a Linux system call called siegeroot. I wrote a tool which is on that link. It's an open source tool to help you escape siege-rooted environment. The name of the tool is siegeroot, and there is the presentation on the last link on the slide if you are interested. Unfortunately, at the job that I'm doing right now, at the MRGFitas, I cannot do my hobby, so I have to do the penetration testing in my free time. So all of this presentation and research was made in my free time. It has nothing to do with my employer, but in case you want to test your device, you can contact us and we can help you. The reason why I started to do this research is that I don't really like the black boxes. I don't really like closed source stuff because you don't have any control over that. You don't know what's going on in your device if you have a black box at home. Probably the most important question about this presentation today is what's the CPE? We already heard the acronym. It's a really fancy name for embedded devices. Usually, CPEs are embedded devices that that was given to you by the ISP or any telecommunication company that you have a contract with. When you have a contract expired, you have to give that device back to your ISP or to that company because it's not really yours. You only use it for a time. Usually, you only have a basic access, web UI access or something like that for the device, nothing serious. So you can only configure the basic stuff on the device, but you don't have a shell. You cannot really control what's going on with the device. And that's what was bugging me mostly. I worked for the second largest mobile operator in the world. It is called Vodafone in Europe. I did ethical hacking and penetration testing, and part of my job was doing CPE testing as well. Vodafone buys lots of CPEs, white label devices from different vendors, for example, Huawei, ZTE, or SHELLCODING. And these are basically the same device what Huawei and other vendors are selling. but these are white labeled. They remove the logo and replaced with the Vodafone logo or whatever. And the firmware is the same. They just modify the web page, for example, the web UI. The reason why, so the vendors don't care about security at all. They are just pushing the latest firmware to the ISP, to the Vodafone, to the telecommunication company. They are selling the box. And before Vodafone sold these boxes, we had to test those. We had to do these CPE testings. And because of that, I gained a lot of experience in CPE testing. I found remote command execution bugs, authentication bypasses, and cross-site scripting in different devices. And I can go on and on, because we found really nasty bugs in these boxes. So we did that because Vodafone wanted to make sure that the customers are safe and there won't be any security issues at the endpoints. And 15 years ago, when I was reading about remote command execution bugs, mostly in CGI scripts, probably you remember these times. These were mostly written in Perl. That it was really easy to exploit these vulnerabilities. And I was really afraid that after they released these tutorials and documentation about how to exploit the remote command execution bugs and how to fix the vulnerabilities, all of the coders and programmers will fix the codes. There will be audits and that kind of stuff. So I was afraid that I won't be able to find any of these kind of bugs in the next 10, 15 years. But fortunately or unfortunately, I was wrong. So you can find these bugs even right now, and probably you will find these bugs in the next 10 years because nobody cares about security. They don't do any kind of audits on their codes. When I exploited lots of these remote command execution bugs, I found out that all of the vendors are releasing and pushing out firmwares with 2.4 kernels, Linux kernels. Maybe you can find 2.6 as well, and you have to be considered yourself really lucky if you find a 3.0 or later kernel, newest kernel. So the device that I'm going to talk about today, it is distributed by a huge ISP in Europe. This ISP has 8 different markets around EU countries. I'm not going to mention the ISP's name because they are really slow. I contacted them 1.5 months ago, and today was the day when they answered that they got everything and they will work on the vulnerabilities. Based on their website, they say that they distributed more than 6 million devices to end users, and these devices mostly covered by the following devices. The first one is the Cisco EPC 3925. It was owned a long time ago. There is a heap overflow in the web server which leads to root. The second one is the TECHNICOLOR TC7200. This device was owned last year by a Dutch researcher, Peter Geisler, aka Blasty. There was a presentation about this on the Hack in the Box Amsterdam. You can find the link in the bottom of the slide. It points to the presentation, what he had there. Long story short, the guy opened the box and dumped the firmware, dumped the memory, and started to reverse engineer the binaries. And in the binaries, he found 2 really interesting functions. The first one is the SSID, the default SSID generation algorithm, and the other one is the WPA2 PSK generator. And he wrote a tool which can be found on that link. If you open that link and provide a valid SSID to the website, then you can generate 6 or 8, something like that, password candidates for that network. And if that user didn't change the passphrase previously, then you can access that network. And the last device, what I'm going to tell you about, the UBEE, I started to do this research on this device. I started to play with it around in 2015. It was a black box test. I couldn't find any serious vulnerabilities that time. And end of 2015, I found 3 different blog posts about this device. There was a guy who opened the box, JTAG'd it, and dumped the firmware and uploaded it to the blog. When that time when I started to play with it and read the blog posts about it, the link was already expired, so I couldn't download it. I wrote some mails, then I had to go on my trip to Africa, and I was sitting in the I was sitting in my tent in the middle of nowhere in the Western Sahara in the desert, and I got a mail. The mail said that the guy re-uploaded the firmware, so I got really anxious because I know that I'm not the only one who is waiting for this, and other people will find vulnerabilities before me and will release these kind of 0 days and stuff before I got home. And unfortunately, I was right. There was a 0-day exploit already released when I got home, which wasn't working that time. I don't know why. So I had to find another one. And since I applied for this conference, there was a advisory from the SEC consult, which can be found over there. They found lots of overlapping vulnerabilities with my vulnerabilities, and the YOLOSEC hacker team released a tool that I'm going to tell you about a little bit later. So the fresh content, the firmware was dumped and uploaded to the website, so I could play with it. That was the 0S goal, which was already fulfilled. And the first goal was to get full access to the box because the 0-day exploit wasn't working. And by the way, that 0-day exploit was to set up a USB key, plug into the device, and get root somehow. So you needed physical access to get root on the box. I wanted to circumvent that, get full access to the device somehow else because it wasn't working and you needed physical access. So I started to play with it. The second goal was to extend the scope of that vulnerability to make it unauthenticated exploit or find another vulnerability which is unauthenticated and get access to the device as root. And the third goal was to get into the network without any prior knowledge. So let's see the goals. The first goal was, I told you that get full access to the device. So I started to play with the binaries, fired up IDA Pro, and started to reverse engineer the binaries, the shared libraries, and looked for injection points. The first thing that I noticed about these blocks in 2015 that it is running light TPD, which is wrapping a custom binary, which is compiled. It's not a script, so it's basically an ELF binary. I found several multiple injection points which could be exploited. This is the first one that I found. Can you identify any kind of vulnerability on the picture? Let me help you. So as you can see, it's ARM architecture, ARM assembly. There is on the top, there is a format string, and in the format string, there is a string placeholder. That string placeholder will be replaced by a user input, which can be anything. And after the printf function was run, the result will be executed by the system function. So if you manage to write something there, then you can execute any kind of code. The second bug what I found, it's basically the same. I'm not going to explain it again. It's the format string is different, but the string placeholder is there. And I can go on and on. This is the third one. And I'm going to show you the last one today. Can you spot any kind of vulnerability here? It's basically the same, but maybe it helps if I show you this. This is the IDA Pro output in a C format. It is easier to read, I guess. The first two lines here, the second and third line. As you can see, there is the V13 and V12 variable, which will be initialized with the SSID, so the name of the network, and the password of the network. And later there is three different, I don't see it now. So there are three different sprintf functions. Yeah, and if you take a look on the second one, there is a format string, again, with 4 different string placeholders. The second and the third one will be replaced by 2 constant strings, the WP, a PSK, and TKIP. And the first one and the fourth one will be replaced by the ESSID and the passphrase of the network. And at the end, the return value of that sprintf function will be executed by the system function. This means that we have a remote command execution bug, at least one in the firmware. And you know, the hardest thing is not to find these kind of vulnerabilities. The hardest thing to exploit those, because you cannot be sure that after you found these injection points that you can invoke this functionality, because sometimes these injection points are in shell libraries, in functions that won't be called in any time. So what you can do is investigate the way how to access that code, and then if you have the exploitation technique, then you can inject your stuff. I wanted to show you and release this exploit on this conference, but unfortunately I cannot do that because the ISP is still working on it. But I can tell you that I have some recommendation how to exploit that. For example, it is better if you use the passphrase injection point because it has the 64 length, and it accepts all necessary characters without any kind of escaping of filtering. So you can exploit that very easily. The only downside of this vulnerability that you have to be authenticated to the network and to the web UI as well. So you need to get an admin password to get there. There is the proof of the exploitation. As you can see, the web server is running as root. I managed to exploit the vulnerability. Basically, I added a new user to the password file and started the SSHD and logged in. What's important here is that the box is running Linux. As you can see, it's a 2.6 kernel compiled early last year, and it's running ARM architecture on ARM architecture. But what's strange about it, it's not using the usual one, the little endian ARM. It's using the big endian ARM, which is not really supported by most of the things. So the first goal was fulfilled. I managed to get the latest firmware, the latest binaries and shared libraries. I could analyze the rest now. Like I told you before, that the second goal was to extend the scope of the vulnerability to make it unauthenticated somehow, and or get an authentication bypass, then later use the same remote command execution. What I did, I started to dig into the binaries again, and started to look at the functions and the code in the web server which is not authenticated, so the unauthenticated part. And maybe you can spot a vulnerability here. Anyone? Let me help you then. So the getenv query string function will have the get request, and if the get request has a go next argument, then its value will be copied into the V79 variable without any boundary checks. The V79 variable is a stack variable with a fixed length. And because we control the value, we control the length of the value, and there is no boundary check, and the variable is on stack. This means a vanilla stack overflow. So I was really happy because I found an unauthenticated stack overflow, which is a vanilla stack overflow, so it should be trivial to exploit. But there are some downsides, or there were some downsides for me. For example, I had no previous experience with ARM architecture. I had to learn part of it. There was no big endian shellcode for ARM. I had to write my own. And if you know the QEMU toolset, it has two parts, the QEMU system and the QEMU user. With the QEMU user, you can emulate a full system like a virtual machine. It's basically a virtual machine. You only need the file system and the bootloader and that kind of stuff. And with that, you can start your own virtual machine and do all the exploitation and testing in that virtual machine, not on the actual box. The other part is the QEMU user, which can only run a single binary, which is not really useful if you want to do debugging, because if you run GDB, you cannot execute any kind of code after that. And the downside here is that the QEMU system doesn't have any support for big endian, unfortunately. So I had to do all the testing on the device, and the QEMU user is not usable it cannot be used at the moment. So what I did is downloaded the build root toolchain and compiled the full kernel and toolset for big endian ARM architecture, and recompiled the GDB server for static and uploaded to the device, which was working really nice. But you have to know that if you do the testing on the device, maybe you get a box, and a box was not working. So you have to call your ISP and tell them that something went wrong and you need another one, which is not really working. So I started to do the debugging on the device. I wrote my own shellcode. That was my first step, and that got merged into the Metasploit. You can find the link there. It is already a part. It's already part of the Metasploit. It took 1 month to get merged after it was ready, because the guys went on holiday and they don't really work that time. If you do if you use GDB server at least on big endian ARM, I have some tips for you, because it's not really working. You have to do a lot of workarounds to use it properly. For example, if you want to do step-by-step debugging, there is no next or next instruction command. It's not working. You have to put breakpoints on every address you want to stop on, which is really tiring and frustrating, because sometimes it crashes and you have to start again the whole process and put the breakpoints again and again. Most of the other features are gone. For example, you cannot list the memory segments and its permissions. So you cannot really tell what's going on there. Of course, you can use the procfs, and I made the first error here, that I had my shellcode and I started to do the exploitation, but it wasn't working, and I realized the stack is not executable, so I couldn't execute my shellcode. I wrote it for basically nothing. I spent a few days on it and for nothing. Then I realized I have to write a rope chain shellcode to exploit the vulnerability. I made it in 1 day, and then I realized that the GDB server turns out the stack randomization and the ASLR as well. So it was a fail from me, but I was still optimistic. I realized that I need an info leak, which is pretty hard to get if you have only one request. When you connect to the port 80, then the web server forks the process, so all the memory address will be new for all segments. So that means that you need to do the info leak in the same request when you do the exploitation, which is not really possible to do. But I was still optimistic after I realized that it won't work. I just found out the Linux kernel, what the device using is randomizing only 11 bits in the address space. So that means that I have one chance in every 2048 tries, which is pretty good because there was the watchdog, which restarts the web server every time then it crashes. So I can just send 2049 payloads in, and it will be exploited. And that was the epic fail where I realized that the CGI is wrapped by the light TPD, which is basically filtering all the special characters. You can only use the English alphabets and numbers. So I did the whole week, the exploitation, for nothing because it's an unexploitable bug. But I had the fallback options here. First of all, the default credentials to access the web UI is the admin user with the admin password. And even if it's not working, then there is another vulnerability that I found. The backup file can be downloaded without authentication if the user previously generated it. So that backup file has the new admin user and password as well. You can still use that. But the last goal was to get access to the network without any kind of prior knowledge. So I started to dig deeper again. But before that, I flipped the box, and this is the back of the box. As you can see, it has lots of information, for example, the model number and the serial number, which is not important for us. But there is the MAC address of the cable modem and the router as well. The difference is only in the last byte. The router's MAC address is increased by 1. And on the right side, there is two different wireless networks. One is operating on 2.4 gigahertz, and the other one is operating on 5G. The SSID and the passphrase is different for both networks, and the default one is the 2.4 G, and is using WPA2 PSK. So I started to dig in deeper, and these are the symbols that I found and really interesting. These are the really interesting ones. From the bottom, as you can see, there are two generate default SSID and generate default passphrase function. With those, you can generate these values, the default values for basically these are the network of the name of the network and the password for the network. And there is the generate telnet password, the generate manufacturer default password, and my favorite two is the get WPS pin base, and I guess they wanted to be funny because it's the get WPS parameter. This is the algorithm of the password generation, the passphrase generation. It's not the full algorithm, but it's not really important. As you can see, there is a format string again. It's using the MAC address as the base of the generation algorithm, and the return value of the format string will be hashed with the MD5 hash function. This means that the SSID, the ESSID, and passphrase algorithm, and even the WPS pin generation is based only the MAC address. The MAC address can be really easily sniffed. You only have to park your car next to the apartment, open your laptop, and it is there because it's public. The only thing that it matters here, if it's using 5G, the network is using 5G, then you have to increase the MAC address by 1. If it's 2.4G, then you have to use the MAC address what's on the back of the box, which can be sniffed. And my personal favorite here is the WPS pin generation is the same. It's based on the MAC address, and this is enabled by default. Nobody knows about this because nobody checks it, but it's enabled by default. What does it mean for you? So what if the user changed the SSID? then you can get the passphrase because it's based on the MAC address. What if the user changed the passphrase? If the user changed the passphrase, you can still get the WPS pin value, and with that, because it's this service is enabled by default, you can get the changed SSID and PSK, and nobody turns it off. Turns it off, so you can get into the network and get root basically in 2 minutes or less. I have a demo, which is a little bit different than I was talking about, a different approach. But first, I have to ask a question. How many techniques do you know against WPA2 PSK? How many techniques do you know to crack it? Anybody? Nobody. So I know 3. First is the online brute force. When you try to connect to the network, try every password that comes in mind, which is really, really slow because you have to interact with the access point. The second one is the 4-way handshake. When you have an authenticated user to the network, you send the authentication packet to the network, the user will lose the connectivity to the access point, and you sniff the whole reconnection process, the negotiation. That way you will have a working 4-way handshake in your capture file, which can be cracked with a tool, and that way you can brute force offline the passphrase, which is pretty slow, but that's the best public thing what you can do against the WPA2 PSK. And the third one is the half handshake, which is not that famous that the 4-way handshake crack. When you have Wi-Fi probes from devices, mobile phones, laptops, whatever, and or you have an authenticated user to the network, and you set up a fake access point which has the same SSID, the same name of the network. That way you can you try to get the user, the device, to authenticate to your network. So you set up an access point which has the same network name but a different password because you don't know that, of course. And when you have that, the device tries to authenticate to your network, and of course the negotiation won't work because the passphrase is different, but from the 4-way handshake you will have the half handshake, which is the 2, and that you can crack as well with the tool. So what I did here, since I started to speak, I started to sniff the ether with my card. Just give me please a second, put my display in mirroring mode. And let me show you the So I'm looking for, right now I'm looking for an ESSID from a device which came from Europe. And if I have an ESSID with the proper name, then I try to crack the passphrase of that network. I'm looking for the, specifically for the ISPs ESSID, which is the default one. We have lots of probes here, as you can see here. Shaka conf and that kind of stuff. Nothing yet. But I have a previous here, previous probes and log. As you can see, here are the networks and the probes as well. This is the ESSID of the European access point, and I will use this to set up the fake network here. The ESSID will be the same, and the passphrase will be howdy Mr. Hanky. I have a cheat sheet just to make sure everything goes well. I start the host APTD and do packet capture in the same time. And if the demo guts are with me, the device will connect to this network. It's always nice to have a live demo because it never works. But I have a video, so I can show you that. Nothing. Great. So let's stick to the video. So I will do the same. Sniff the ether. First, I start the network interface in monitor mode. Stop everything what is not necessary, and start to dump the ether. There will be lots of stations and probes. There is the probe. As you can see, the TST 75 and so on. Okay, so I modify the host APT's config. I pull up access point with the same name and start the host APTD. Yeah, nothing yet. Oh, here you go. So I went back to the to the live demo, and as you can see, somebody connected to the network, and I'm sorry. Let's stick to this one. In the same time, I'm doing packet capture, just to have the half handshake. The access point is now up and running, and in the other window, I do the packet capture. We have to wait a bit. I hope this works from the video. So as you can see, there is the invalid MIC in message 2 out of 4 of four-way handshake. So we have the halfway handshake, and it is captured. It is in the capture file. It tries to negotiate again and again because the passphrase wasn't working because it's different. But still we have different halfway handshakes. We have the packet capture. I stopped the fake AP, and I have my tool which generates the password candidates for the given SSID. So if you know the network's name, you can generate the password candidates for the network. I just copy there and copy into a file as well. So it starts to brute force the password candidates. It basically generates all the MAC addresses, and if it has the same network name, then it writes out the passphrase as well. It has 256 iterations, a little bit slow. There will be a few password candidates. There is 3 at the moment, 4, 5, as you can see. These are the default passwords for that network. I copy those password candidates into the dictionary file, which will be used for the brute force attack on the halfway handshake. I already saved it, and I start to brute force the halfway handshake. I only have to state the capture file, what I just did, the MAC address of the network card that I'm using, and the name of the network. And as you can see, after a few seconds, it already found the passphrase. So now if I set up the same network again with the proper password, the device will connect again and the negotiate won't fail. It will succeed because it's the same, it is the correct passphrase. And that way I can attack the device as well, not only the network. So it can be used in a remote attack as well. Thank you. I'm not sure I earned it, but thank you. So the next one, if you are looking for these devices in Europe, maybe it's the easiest way to just open the web page of the vendor. There is a map, and if you can spot out the blue dots on the picture, those are the modems. So it's an interactive web page, interactive map with all of the modems. Not all of these are UBEE devices, but I think a major percentage they are. If you need more bugs in the firmware, there is an authenticated buffer overflow. Again, in the firmware upgrade process, you can control the file name, and even they are using the secure version of the string copy function, the string and copy function, but they don't really do boundary check here properly. So you can control the length, and you can do a buffer overflow here easily. If you dump the NVRAM or the heap of the web server, you can find really interesting stuff. For example, there is the telnet ID, which is the username for the telnet, and the encrypted password of the telnet user, which is encrypted by Descrypt, which can be cracked easily in days or hours. But if you dig more deep, you can find the same password in plain text form, so you don't even need to crack the Descrypt, which is pretty strange. I don't know why they put it there. And there are more and more vulnerabilities. I already told you about the previously requested backup can be downloaded without authentication. There are lots of plain text passwords all over the device for different reasons. There are command injections and remote command execution bugs, which I didn't tell you about. And there are 3 backdoor users in the password and shadow files for different reasons. I don't know. So what's the impact of this presentation and bugs? Mostly the bugs. Based on the website of the ISP, they state that they have at least 6 million devices distributed to end users. A big percentage of that using the UBEE device with the same firmware. So I would say at least hundreds of thousands, maybe 1 million devices vulnerable at the moment with these kind of vulnerabilities. The ISP is working on it to fix it. But still, anybody, since the YOLOSEC hacker team released a tool which is basically the same password generation algorithm that I showed you with the WPS pin generation. If you have the name of the network, you can generate the password candidates and log into the network. So basically, anybody in Europe have access to the neighbor's network at the moment because they released this algorithm. I didn't want to do that. I think it's not really responsible, but it's not my call anymore. If malware writers or black hat hackers have access to this information, they can create botnets or use the routers as jump hosts or Tor gateways. And if you read the latest Snowden leaks, then you know that the secret agencies really like to use routers and endpoint devices to do man-in-the-middle attacks on people. So this is really easy to do because nobody knows what's going on in the device because it's a black box device. It's closed source, so you cannot really tell what's going on in the code. And the impact on you who is sitting here in the room or living in the US, is you cannot be really sure what kind of devices you have at home, what kind of devices you use in your everyday life, because probably the ISP is working in the same way like in Europe. So they're distributing black boxes to you, and what you don't have access to it. Thank you for your attention, and if you have questions, then now is the time, if we have some time left. If not, then enjoy your lunch. Thank you. Any questions, maybe? There is one.
What made you start hacking at 13?
I don't know. I was 8 when I got my first computer. I started to code, program, different programs, and I was, you know, it was the good way to start. I wanted to understand how programs and other stuff works, and sometimes I got some root shells and so on. Any other questions? No. Then thank you very much.